Hi, how are you?
Good, how are you?
Okay,
Happy New
there we
Year.
go. How was your holiday?
Good, that was good.
Are you back at school new term yet, or?
Yeah, right. I've already had my first week of class.
Oh, wow, okay.
This semester's classes are very interesting. So I'm taking deep learning and um, there's another class called Quantitative Systems Neuroscience. Both of them are pretty interesting. Not only for the course materials, but also those courses are like asking you to do like a project, and you have to like do proposals and reports at the end of the semester.
Oh, wow, okay. That sounds good.
Yeah. For the deep learning class, I'm currently looking at which topic should I have. You know,
Yeah.
it's like that the topics must be very novel, not just make me view.
Oh.
Yeah, I'm still like. Do you have any idea about that?
You
Like
mean
deep learning,
pro?
computer vision, NLP, or probably self-supervised learning, stuff like that.
Like, are you talking about like topics for research? Oh. Well, I mean, yeah, there's a lot of. I'm trying to think back, like last fall when we did the ML sessions, and I kind of got into a lot of the stuff because I've been interested in it, but also I had to do presentations on some of the topics. So I was thinking there's a lot of interesting stuff in the area of generative adversarial networks, or GANs. Just people trying to use them on different area domains of knowledge. So they use them for art, but they also use them for a number of other uh, domains where there's data that you can work with. I think language is also interesting, like a lot of the language models that they've got out there. It seems like that's a pretty rich area. I mean, it's easy to get data to train your models. So then there are also models that what they call attention models.
Hi, Stefan.
Hello.
How are you?
Hi, Ziyi. Hello. I'm good, fine, thank you.
And so they're like models where they're like analogizing brain functions. So they're like attention models or different models of memory that people were experimenting with. So,
Cool.
do you have like input data that you're thinking of using to like train the models, or are you just?
No, I am currently just looking through papers to get ideas.
Okay, yeah. So I mean, yeah, like it's a very big literature, so it's really hard to kind of focus down on certain areas. But I think those are like, at least to me, some of the more interesting areas. I think with like brain function, if you're interested in brain function more, there's like a debate about how realistic deep learning models are to the brain. So like, some people argue that deep learning is pretty close to what we do in the brain in terms of processing information, and there are other people who think it's totally inappropriate to make that analogy. So there's like this sort of this debate, and then there are actually people starting to use deep learning in a way that's analogous to the brain. So to come up with specific networks that maybe mimic different features of the brain, like when they use them to look at attention and things like that. So that might be another area too. I don't know what the state of the I don't know what specific papers I could point you to show you that, but
Thanks.
yeah. So Stefan, how was your holiday?
You mean mine?
Yeah,
Sorry?
yeah.
Oh yeah, it was great. Thank you. I worked on the manuscript a little bit.
Yeah, I saw. Yeah.
And exactly, we can talk about this if you want.
Yeah. Good. Hello, Jesse.
Hey, Jason.
How are you?
Okay.
Good. How was your holiday?
Oh, me?
Yeah.
Oh, it was good. I didn't quite get to do what I would like to have done in the group stuff, but overall, it was mostly restorative, which was needed.
Yeah. Oh, good.
How
Yeah.
about you all?
Stefan is going to come back. Yeah, there he is.
Yeah.
All right. So, yeah, welcome to the meeting. Welcome to 2020. I hope you all had a good holiday, and it seems like you did. And we'll keep going in these meetings, and we'll, if you want to, it's pretty free form, so if you want to bring up anything, you want to present anything, you're welcome to do so. Just let me know, in advance, and we can prepare for it. I got an email from Ankit saying he couldn't make it today. He's going to watch online later, so he's doing okay as well. So on the agenda today, I wanted to get back in touch about the manuscript, go over that a little bit, go over the fQXi essay, which I mentioned in the email. I'll explain what that is. And then, Jesse, I noticed you started something called Frontier Maps. Maybe you could tell us a little bit about that.
Okay.
And we could discuss that a little bit, see what that's all about. So, let's see, let me get the manuscript link in the chat. And notice that Stefan did some work on it over the holiday. He emailed me for the link, so I sent it. And yeah, you put in all the stuff for the methods and some of the other stuff. So let's take let me see if I can share my screen here. So can you see my screen now? So this is the manuscript. In case you haven't seen it in a while, it's gotten a little bit more detail in it, but the title, if people are still satisfied with that, or if you want to request a little bit of a change, that's fine too. The authorship order is yet to be determined. I'm trying, we can decide on that right before we finish it. And then the abstract is, I saw that Stefan made a slight change to the abstract, and I made a slight change to the abstract. So usually I would keep this around 200 to 300 words. It's probably good because different places you submit it, they have a different word limit, but 200 is usually pretty good. Also, a word about titles is that typically titles are better if they're shorter. So you'll see titles sometimes that have 7 or 8 words and then a semicolon and then 7 or 8 more words, which is sometimes okay, but it's like you want to keep your title shorter. So that's why I've kind of made it really short here. And sometimes that's more effective. It stays in people's minds more. But introduction. So we have an introduction, still kind of the same. I just turned back to this paper from 2 other papers, and how, just resting over the holidays. So, I'm going to get back into this more in the coming weeks. But the introduction, again, if you have any changes to propose, you may. We have the motivation, the suitability for Brainberg vehicles for modeling development. And here we have 3 points that kind of sell this idea. Then we go into neurodevelopment and brain networks, development and connectionism, and then we get down to embodied cognition, which is Jesse has a couple of notes here. So we talked about this in the notes. We talked a little bit above on embodied nervous systems, but I may see more here if you think it works. So this is a good overarching theme, and then you sent me another email about some stuff you were reading. So do you have anything to say about that, Jesse?
Sorry, could you say the question again?
Oh, just about the embodied cognition section. So you were reading some stuff on embodied cognition. What are your current thoughts on that?
I don't really have something to say about it right now, but I think that would be a good thing to put in there, and flesh that out a bit more.
Yeah. Yeah, I mean, let's see, what is this note here? Did I say? I said we need some review in embodied systems. The embodiment literature is a bit tricky, so there are a lot of alternate definitions. So, I mean, the way to sort of get at this maybe is to, maybe a way forward here is to say that there's a definition of embodiment that we can use to sort of characterize what's going on here. And then that definition, we can just build on that a little bit from the literature. So, like what we're doing with Brainberg vehicles is, there's a specific embodiment point of view. And you sent me a couple people you were looking at in terms of their publications. I thought that was good. I think it was Anthony Chermolo or something like that.
Yes. I've been looking a little bit at his work, and I think he'd be a good person to mention here, at least.
Okay. Let's see. Yeah. And then, we have it grounded in like a specific definition of embodiment. Because there are probably at least 6 or 7 definitions that people are working with. And so, if you go through all those definitions, that's a lot of review, and it's not all necessarily very relevant to what we're doing here. So I think I was looking at it, I think he would have, his work is sort of pretty focused on what we're doing. So it's let me see, maybe define embodiment and clarify this definition. All right. So that's a good way to do that. Let's see. Yeah, I think this is just more. This conversation is more about the embodiment. Okay. So, and then we can also put some of it in the discussion if we really find that there's a summarizing set of ideas that we, that if put that up in this section, and then we can like sort them out later. A bit like what I did with the descriptions for Stefan's write-up, although most of that ended up in one section. So, then their generalized models of regulation. So that's the next section, and this is just kind of like going through specifically what's relevant to the techniques that we're going to introduce. This might be a little, well, this feeds into this feedback and regulation section, which was also a Jesse thing, and this is something that you're interested in with the EGRT, but I don't know, like, if you have any further thoughts about that.
Not particularly,
Okay.
but I think it will come in as I continue with the other parts.
Yeah, I think that I don't know how much time we want to spend on it again. Like, we could do like a 10-page review of it, but that's not really what we want to do. So, let me go over it as well, and then see where we are maybe a little later forward in the process, because I think I have some things here. I don't really think these are complete thoughts. I start writing something, and then I get to kind of putting down some basic references, and then you come back to it later. It's kind of why I have it yellowed out here. But if you want to think about it more and we can discuss it more, that's fine. So then the methods. So again, this is just kind of getting into the methods for each software instantiation. So this is the Rajan Brain. This is thank you, Stefan, for this description of what your approach. I rewrote it a bit, but I think this is good. You have the software that was used, the basic description of what's going on.
Okay. Yeah.
Oh yeah. And then let's see, environment and body. Oh, this is all from the thing they gave me. I restylized the code table, and then what else? Oh yeah, the equations. So what I ended up doing with the equations was rewriting them in Google Doc, and I didn't want to do that, because it was having trouble like rendering things, so I just rewrote it. Mm-hmm. And I don't know if I may end up doing it in LaTeX, in a different version of them, but I think everything seems to be for Z and for Stefan, they're both sort of in place here. So now we have, so this is for Stefan's write-up. So vehicles, movement, brain, and development.
Mm-hmm.
And then for Z stuff, Fabian algorithms.
So I actually had a question about my part of Writeup. Okay. And that'd be, wait a sec, I'll just open the manuscript to be speaking on, I think. It is, here's the manuscript. Right, so if we actually look at the very ends of my write-up, where it's going all about there was some part where I kind of tried to explain the genetic algorithms approach that we take.
Yeah.
Have you deleted it? Could it be? Okay, so it's not in place like at all. Or we don't want to add this at all.
Oh, which one is it? Well, I had the part, I thought, well, maybe I put it down further in the paper. I don't remember.
Okay, so there was just some parts where I explained basically what's the general approach is. So here I just take down on the details of brain and how it is basically. So it's about this graph. we have these nodes that represent neurons and edges that represent
Oh,
synapses between them.
yeah, I put that later in. We'll get to that
Okay.
that section. But
Okay, yeah, sure.
but I want you to
sure,
look
then
at
it's
it and
fine.
make sure it's So
So maybe just my suggestion here would be that maybe we then kind of change the heading here and just delete the development part, because it's not really about the development here. Then it's about brain, like as it is, and how we represent it.
Oh yeah, so
Isn't it?
this heading here.
Yeah,
Okay.
this development.
Yeah.
What do you think? Or
Yeah, I guess maybe brain network or brain network.
okay, yeah, that's fine on me as well.
Yeah.
Yeah.
Or formalism, maybe that's a good word. Yeah, because it's so then this is the part where you talk about it being a DAG, and you have some math here on the different ways that connectivity matrix can be.
Okay, yeah. Seems fine.
And so, yeah. So then, okay, so I think I've gotten the equations in a pretty good shape here in terms of the formatting. So I have the stuff from Stefan, and then the stuff from Z, which is, again, hasn't changed, but I've actually been able to render these equations, because I couldn't get these to render in Google Docs, from like LaTeX, so I had to go back and change them a bit. Just re-enter them in the way that they have it. So everything, I would suggest for Z and for Stefan to go through these equations and look at make sure that the terms are I properly define the terms. This one in particular might be, I noticed this one didn't have any, the terms weren't described so this was W sub ij is the connectivity matrix. I don't know if all these terms, maybe we could use maybe a description, a little bit more description about that. But I don't know if I have that right.
So you mean just write more with words and less with equations, so to say?
Well, no, I mean go through the equations and then make sure that all the descriptions are correct. So here you'll have the equation, then you'll describe some of these variables down here in parameters. So the different parts are described. This one is the ith feature of the odor emitted by stimulus source K. Is that correct? I think that's correct because Z put that in there. But I want to make sure that they're all correct according to the way you had them in your head when you put them down. So this one, I didn't really. Well, some of these terms aren't defined. I don't know if that's a problem, but I think it's probably straightforward as to what's going on here. But if you think it makes it easier for people to know what the individual terms are in the equation, that would be good to put underneath. Again, I'm just trying to make it easier for the reader to understand the math.
I see what you mean.
Yeah.
Yes.
So, I mean, it's always better to have underneath to say, oh yeah, this part of the equation means this. And, but just to say it in one statement, you don't have to go into a deep explanation of it. Because,
yeah, true. And so just my thought was that I'm first kind of defining this graph, and I say that it's a graph, and I also represent it as a tuple of V and E sets, and then I explain that V is a set of neurons and E is a set of connections between neurons.
Yes.
Yeah, so that's kind of should be all right. Yeah. Then I say anything what I do downwards. Well, I also define weights function that maps from edges to the interval from 0 to 1, and then I just basically reuse the terms that we already had. So I say the yeah, kind of what it has to fulfill. This weight function is that for each V from big V, which is like explained set of neurons, this has to be the case that all weights sum up to 1. And I also kind of explain it in the text. So I think that shouldn't be that hard for reader to comprehend this, in my perspective. But maybe, you know, maybe it's only my opinion. It would be, of course, good if like we could all read this part somehow, and just, you know, when people leave comments that it's not understandable for them, I will of course change it according to the feedback.
Yeah, I think that would be a good idea. So if people want to, they can go through these equations and like if you find something that doesn't make sense, just put a note in, like a note on the side of the, you know, just insert a note in the document and say that, you know, what does this variable mean? Yeah. Does it mean this? And so we can go through and address them, and then like put in, because I mean, it's all, you know, I just read an article on how people are reinventing the manuscript, and like one of the things they're doing is making like interactive parts of the manuscript where before we just, you know, sort of statically define things. And I don't know if we don't want to do that here necessarily, but you know, it is better if you have, like, if you demystify the equations a bit. So
yeah, sure.
Yeah. So then again, we go through. That's for Stefan's part, and then Ziyi's part again. You have equations, and we do the same thing with that. Just kind of, this one is pretty well defined in terms of its components. So make sure that everyone understands that, they feel comfortable reading it, you know. And then, so they're all numbered properly now. We have a judgment unit. So that's all through that. And then now, I don't know what NCAT has in terms of equations, but we would put them right here. So this is, and so we'll just leave that for him to put in his things. And then the numbering would follow from that. All right. And then we get into the part with talking about code. This is for Z's part again. I kind of divided it up a little bit differently than with Stefan's part. Maybe I'll go back and reorganize it a bit, but I don't think it needs to be reorganized that much. Just to make sure it's all consistent. And then NCAT is yet to give me his method, so we'll put that in here as well. Actually, maybe we'll just do this. We'll put that underneath this. That's right. Well, we'll see how it works. I may have to reorganize that a bit more, but that's okay. So then we get into the results. So we have this little part here, sort of introducing the results. They're not traditional results. They actually just are the software instantiations. And this is where, for Stefan, I put your other part of the description. So you're asking about that. I actually added in a couple of screenshots of the environment. So there's one of the control panel here, and then there's one of the environment in operation. And so you have, and I colored the vehicles in red so that people can see them more clearly. And then this is just like, again, like a little screenshot. It's not of anything in particular, but you know, I think that's good to have the screenshot. And then I think this part needs a little bit of an introduction here because I pulled them apart. So let me put in a note here. But I think what you gave me is pretty good. I mean, like, you know, I'll rewrite it a bit for, you know, to fit it into the paper a bit more, but I think it's pretty good. Then you have figure 3, which is the agent properties here. And this is the agent brain graph. That's pretty good. That shows it's an abstraction, but it shows what's going on. This is the section one of the sections about what's going on with the DAG. I haven't read through this really at a really fine grain level, but this is basically, it looks good to me so far. And then we move on to Z's description here for his, and this again has a screenshot with some more detail about his model.
Sorry,
His
I have
model has
one
a
more
lot
thing
more. What was that?
the deck first. Yeah, the deck that I had.
Yeah.
So it's basically just like it's totally cool. The screenshots and stuff. Like, thank you very much for this and putting this. I was on it. I mean, I guess it's the place, and it's just basically, I think the good results that we have. The deck thing. I was just thinking that it may be more kind of a meta thing still, because there. I also wanted to talk about it because there I could also add like a bunch of equations. Basically, what I do in this DAG paragraph is I basically vaguely describe the whole evolutionary approach that we have behind mating vehicles. Like crossing over, mutating vehicles, then selecting them. And I kind of explain it pretty unmathematically what is basically happening from the methodological side of view.
Yeah.
So I was still thinking, like, would we still leave this section here in the results, or would we put it back in methods and I would like just extend on it a bit, like what is happening there mathematically? Because for me, it's like both things are fine. It's just maybe about how we. Like, are we sure that the reviewers would accept it like it is without like mathematical explanation? Maybe also the place that we have, because the manuscript is already 224 pages long. So I don't know how it is.
Yeah, I think we can keep it this way. We might like rewrite this section a bit. So I think maybe we could rewrite this a bit to like. I think we have enough mathematical formalism. So we could rewrite it and then perhaps add in another showing the evolutionary process. Because a lot of the papers I've seen in like evolutionary algorithms and things like that, they often do have like diagrams showing the process of like recombination and things like that. It's easier for the reader as a visual, where they can see, oh yeah, this is how it works. Because otherwise, if you just put it in math, people might not like. There are people who really understand equations and people who, really understand like a diagram. If you show them the process in a diagram, they get it. And so I think we already have a lot of math. Maybe we could also just have like a diagram where, we show a basic sort of how selection works in this case. I think that would work.
Okay.
Yeah.
Yeah, well, we'll just review this once again and add some more information then.
Okay, that sounds good.
Good.
So again, we have Z's stuff. So he has his screenshots here, and he has the model. So there are diagrams of his models here that are extensions of the equations. In his case, he doesn't have to explain like the evolutionary process, but he has the different network components. And then this again is Ankit's area. So Ankit's description would follow that format pretty closely, where you'd have like a couple of diagrams and maybe a screenshot or two, and then a couple of diagrams of some of the processes that are going on. And then the discussion and future plans section, we have the use cases, and I wrote up a little bit about the TSP and spatial cognition part. So if Stefan wants to look through this part here, if you think it's good, or if you want to add to it or modify it, you may. The hinge connecting behavioral and neural models, I have to go through that again and make sure that it fits together. I don't know if there are any other potential use cases people are thinking of, but I think, this one I discussed with Ankit Swarm Intelligence with Breitenberg vehicle behavior, so we can maybe add that one, and I think that's probably enough because we have a lot in the manuscript already. And then the final section is a follow-up on some of the concepts. So here I've kind of worked it out a little bit where I name a couple of issues here and then maybe some future directions. So this is, again, something that if you're going through the manuscript, you might comment on or add to or whatever. And then our references, we have, how many references? 51 so far. So we're actually pretty far along in the write-up. I think we have a lot here. So I think the strategy now is to just kind of go through and add things where we want to add them, or we mentioned. Don't get over excited about writing voluminous amounts of stuff. We want to keep it brief at this point. If we want to, change things, we can, but I wouldn't add a lot more to it. But yeah, that's the state of the paper. I think we're coming along pretty well on that. I don't know what about it. Originally I mentioned a deadline of the end of last year, but we obviously didn't make that. And that was a lot of my fault. I didn't have time. I was working on other things, and I didn't want to make people work, or I didn't want to work on it over the break. So we can, maybe shoot for something like March 1st as a good deadline to at least get it done and maybe get it on a preprint server, and then maybe get some feedback from people and submit it to a journal. I think that's a good timeline. So would give people a chance to think about it as well as actually, put things in it. So that's the manuscript. Now I wanted to move on to a couple other topics. We have any questions about the manuscript before I move on?
I would just say I think that's a good timeline. My brain has not been in manuscript space for a while, and I feel a little bit in a fog from that. So I wasn't very present recently, or I didn't really contribute much to this meeting. But it's definitely going to be something that I am fleshing out in the next couple weeks. So I think I like the direction it's heading in.
Yeah, it's definitely it's hard to get back into the space of the manuscript. So yeah, I definitely agree. You got to get, as I find that when I write papers, if I go from one paper to another, it's you have to really kind of spend a little bit of time getting reoriented to it. So yeah, it's definitely something. If you want to contribute, I would recommend reading over it for a while, a little bit, and then putting in your contributions.
Yes.
Yeah. So that's good. So yeah, let me know if you have any other questions, or if there's some question you have on this, on the some part of it where it isn't clear. So the next thing I wanted to move on to is this fQXi essay. So I mentioned this. I don't know if any of you are familiar with this. I think I mentioned this to Jesse over the break. I don't know. Let's see.
I saw it on Slack or something, but I don't know anything about it otherwise.
Yeah. So let me share my screen again. So this is something I've been involved with for a couple years. They've had them for probably 6 or 7 years. Let me see. This is it. So this is fQXi, and it's a group that's interested in theoretical physics, but it's pretty broad. So they have a number of topics that span cognition and physics and mathematics. So they have had a number of essay contests in the past. This is their their stub on the essay contest. So this is their community. fQXi stands for Fundamental Questions. And so fundamental questions means, like theoretical questions or things that are like, more fundamental than like analyzing a data set. Yeah, they really are referring to theory, but the way they refer to it in physics is fundamental questions. So you get a lot of very weighty topics. One was, what is fundamental? So that was, I do have the essay that I contributed to that. So that was an interesting topic. Wandering towards the goal, which actually I also participated in. That was an interesting one. It was kind of like they talked about it in terms of mathematical laws, but there was a strong cognitive component to that. So, I mean, there are a lot of things, a lot of directions you can take. And what you do is they have these essay contests they sponsor. You have a team of people or an individual, you write an essay and you submit it. The essays are, when they say essay, it could be from like 4 pages to 8 pages with references, some references. Some people write entire papers and submit them, but, they have to be like, they don't have to be the length of this manuscript that we're working on, but they have to be somewhat like complete. They can't just be like some brain fart that someone had and they put it down. You have to do a little bit of research into it. So this contest that's ongoing now, deadline for this is March 16, is undecidability, uncomputability, and unpredictability. So that's a mouthful. I didn't write that topic name, but basically what they're talking about is like, I think it's the intersection of like theoretical computer science, like things like the Turing test, and then like, statistics or statistical methods and empirical methods where you don't know things, you can't necessarily predict certain things. So let's say we had a comment in the comments.
Oh, that was just for other things.
Oh, okay.
I won't be able to say too much after our usual lending time.
Okay, so let me get this down, and then we can talk about your stuff. So this, I just wanted to put this in here. Let me send this link for people. And so that's the gist of this essay. And so what I've been thinking about this for a bit, and I've come up with a stub on GitHub, and this is sort of an outline of what I'm interested. I think where the direction we should go with this. So this is you can read through it later, but it's basically a way to kind of get at this problem. It kind of focuses more on unpredictability, but there's a number of themes. So I wouldn't suggest like going over every theme and trying to unify everything, but this is the outline that I've come up with. So let me put a link to that in the chat as well, so that people can get, if you're interested in it, you can go look at it, and then maybe if you want to comment, you can just issue a pull request and, maybe make some edits or whatever. So it's like, you have an introduction to the problem. How are we going to approach the problem? What makes a problem hard to represent, which is kind of like the, computer science aspect of it. And then questions that result from these issues. And this is just a very basic outline right now. I might have a meeting on this at some point if people are interested, or else we can talk about it more in coming weeks. But I just wanted to give people an idea of what that was all about. So if you're interested in contributing to this, just drop me a note, or you can issue a pull request to this repo, and then we can keep going, and we'll be talking about it more. The deadline is in March, so that's a ways off. So now I want to turn to Jesse with his frontier maps, because he has to leave it right at 10, or 11 his time. So Let me see. So Jesse, do you want to? I have your frontier map stub up. I went to GitHub to look it up. Do you want to talk about this a little bit, or?
Yeah, and just about the essay, I am interested, and I mentioned briefly in a previous meeting that I was really gonna. I got a scholarship to go to the New England Complex Systems Institute because a lot of that felt pretty related to complexity science. But unfortunately, I can't. I wish I could. I wish I was going to that, but I unfortunately couldn't make it due to financial stuff and timing.
Oh.
So I really wish I could have done that because that would fit really well with that essay. But I still am able to participate in different things like that in general. But I'm quite interested in the essay topic. I'm curious to see where it goes, but we can talk more about that later.
Yeah, I think we can. Yeah, I mean, it'll be like just a matter of like fleshing out ideas and then writing it up. But that's we have to flesh out the ideas first. It's like if it doesn't make sense, then it's not going to be not a very good foundation. But
yeah.
Yeah.
So as far as the frontier map goes, that's sort of a personal macro framework project. It's going to it's mostly just a tool. Like it's mostly a tool for myself to deal with a lot of different subjects that I want to know more about, and they kind of hover around the space of there's cognitive science, there's computational science, there's maybe some biological things that I'll get into. But it's on GitHub, so ideally what I would like to do is have some learning resources and some coding, like very simple coding projects, if you will, or examples that help delineate trajectories. It's mostly like why it's called frontier map is a lot of the stuff I'm interested in sort of on the frontiers or intersectional transdisciplinary research fields, but I'm the major impetus for the project is what are these sort of trajectories of thoughts in different fields, and there's no way like this is not at all going to be like, oh, I'm just going to spend the next year researching stuff and then putting it into these categories and I'm going to have this thing appear in a magically nice sort of concept map. It's much more going to be a project that I put a lot of sub-projects underneath, but hopefully weave some broader narratives different to how different fields of study have developed. So that's a bit airy-fairy, it's a bit overview, but like one of the most concrete things about it is I guess I could go there, but I was really interested in, if you guys have noticed the Gary Marcus and Yoshua Bengio AI debate, and I hoped, I kind of stumbled upon early stuff about perceptrons prior to the debate anyway, and then like very, very early computer science stuff and neural network stuff that's somewhat archaic and then also somewhat relevant. And the AI debate was very interesting because you have Yoshua Bengio, who is one of the very, very steeped in the history of computer science and particularly deep learning stuff, and Gary Marcus, who's more of a cognitive science person. And I was very interested in that debate because it's interesting in as a specific event that will help illustrate some past trends of thought in computer science, in deep learning, and then Marcus is kind of a benevolent and somewhat antagonistic critic, saying more biology, more cognitive science stuff, and he's not as versed in computer science, but he's very much trying to promote discussion about it. So I tried to collect a bunch of resources on it, and kind of I find I see it as a nice point of reference for trying to understand certain developments of thought in this case, computer science or what we're calling AI now. So it's a nebulous project, as a lot of my comments tend to be here in this group. But what I guess the relevance for this group would be, or at least for me talking about it in this group, is a lot of the things that I know orthogonal lab has a potential education aspect of it, and is interested in things like open science, and is interested in, we're doing different things to help kind of create frameworks of understanding, and I ultimately see a lot of the projects that I'm working on as fitting into fleshing out the broader narratives and the broader map in general. So that's a very unplanned overview of it, but I'm happy to talk more about it if there's any other comments.
Yeah, thank you. That was. I'm impressed with just looking it over what you've been able to do so far. I like the idea of having these kind of stubs for, kind of like references. So let me put this Marcus Bengio link in the chat. I was talking to Z earlier about he's interested in like taking classes on deep learning and machine learning, and so he was asking me about current trends in the field, and so that might be of some use. I would look into the Marcus Bengio debate. See, that was a very good event. They talked a lot about kind of the fundamental aspects of deep learning there, where like in terms of, they were asking questions like what is deep learning and does it relate to what's going on in the brain. These are old debates for artificial intelligence more generally, but especially now with deep learning, you're getting things that sort of resemble what's going on in the brain. But we don't know for sure that this is the way the brain does it. We assume it does because there's like this connectivity and that it's doing things that look like what's going on in the brain, but we don't really know. And so I like the idea here in the frontier maps of. So it looks like you have a couple of topics. You have AI, ethics, philosophy, and so to break things down into different areas of inquiry, and then have like specific topics within those, like the perceptron from Rosenblatt, that was a classic paper, or like a debate like Bengio Marcus, where they kind of bring up a bunch of issues simultaneously. I like that. I have like something like that in the orthogonal lab GitHub on cybernetics and systems, and I don't know if you've seen this, Jesse, but this is like a collection of stubs that I've been assembling. This is not as detailed as what you have there, but this is something I came up with independently. But this is just something that I'm using to collect things. So like suboptimality is a topic. And then, you have some resources. These are resources from the work that I've been doing and some of my colleagues. So this like from the NetSci conference, I did a presentation at a workshop a couple years ago, and there's actually a presentation from a couple years before that at a different conference. And then to have some, to like come up with some topics in different areas, like if you talk about suboptimality, where do they study that? Well, they study in evolution and complexity. They study in perceptual decision making and something called component placement optimization. So in that case, we're looking at different domains and where this has been applied. So this is again like what you're doing is very at a very general level, but it's like it might be we might work together on this quite a bit if you're interested in kind of shaping this into a nice resource. I like this idea. You were telling me about this before, where you have like resources for people who maybe are going in one direction in their research and they need to find out more about different areas Like, you might be interested mostly in philosophy, but you want to know about the brain. And I mean, this is like the
Right.
whole principle of interdisciplinary research or education and research. But we have, we have to have resources for that, and I don't think there is a very good set of resources right now, especially if you're doing this informally.
Right, and that's why like that what you're saying touches a lot on the impetus and just this, for lack of better terms, disappointment and or frustration in there not being one. But then also like you can't realistically, it's very understandable why there's not just like some magical textbook that contains all of these overlaps that I'm interested in. Like that, like it's understandable why that's the case, and if I had infinite time and resources, I would probably love to just spend a couple of years straight, like doing that. But that's not going to be the case for me because I work and I'm going to be going to grad school, and I'm probably not going to be doing this directly in grad school and everything else, and we have our own manuscript and all this other stuff. But in the meantime, as much as I can try to work toward, it's kind of like one brushstroke at a time for to make a painting very, very slowly. And then there are things like there are there's concepts, and there are, especially in like the computer science and AI stuff, there's some specific under like I found some very simple codes for like 1958 version of what a perceptron looks like and does, and like, okay, you can see it and you can play with it, and ideally getting to a place where I could I'm developing like maybe a simple Jupyter notebook that would help some interactiveness and that, and like that's that's good, and that's also training for other more like we were talking about in the paper, having some more interactive stuff in our paper, or maybe associated components. I know they came up in past discussions about our manuscript, but I think that's all that's interesting stuff, and it'll be a slow burn, but over time.
Well, I had also talked about Ankit, or with Ankit about that at the end of last year, about like creating a interactive like educational tool, and then something that people could use and perhaps pay for more advanced use. So a lot of the complex systems groups have their own set of simulations, and I think they've managed to get funding for those and develop them. So like they're doing things like looking at like how does emergence work. They have a set of simulations for that. It makes it really easy to demonstrate that. And so in this case, you might point people just to those simulations since they're already built. But then something very niche, that no one's thought about before, like simulating some very obscure process in AI, or something about the brain. That's something we might be able to develop ourselves, or whatever, to drive that point home. And so there's a lot of potential there. I do think that like having educational resources, it's never you think that it's a saturated market, but there's always a way to help people learn better, and it's it's tricky because people learn in different ways. So whatever facilitates that, I'm all for. So we can talk about that in coming weeks as well. So yeah. So well, thanks for everyone for meeting today. I wanted to ask if there are any other questions about anything.
Yeah, well, I'm gonna have to head out, but thank you guys.
Okay.
Okay, sure.
Oh, Stefan, you had a question?
Yeah, it's more like a discussion. So I have an input, just not to forget about the project, that like this frontier map stuff. I try to be like down for like a minute or two. So it's basically what's coming to my head is that the project, like I really like the idea. Okay, so it would be also useful for me, as I understand now, to learn something as a computer science, so to say, undergraduate, to learn something about like cognitive science if I wouldn't be going to do masters in cognitive psychology. like on the interface, I guess the idea could sell. But when we are talking about that we are developing this course, it is of course like I kind of understand that we are talking about bringing many different niches here together. And if we do that, it like also means that we are kind of like we do understand what's in what's happening in each single niche, if not even revising it or like shortening this, this amount of several publications and several trends, trying to put them together in one frontier and call it a frontier and say, okay, people, you know what, in cognitive science, if we are talking about perception and memory, there is this and that trend that we can see. And it all means work, and it all means that we are also professional in each single niche we are working on. And so I thought about, that we would probably need to invite some professionally working people for each of the niches that we are wanting to get in this curriculum, because I kind of not really sure that we as undergraduate students that maybe just themselves start to look around and see what is happening there, like maybe not even on that professional level. We don't have any PhD yet. We'll try to like get in several niches and like pick some informations out, without having an overview of what's happening, without being professional in this niche, like for some 10 years or something. Reading papers, like you don't have, if you haven't been reading papers for like a couple of years in some narrow topic, you can't really say what's like worthy and what's the trend and what's not, and maybe which paper repeats another, but just with different words, all of these things that we would need for the project.
Yeah, I agree. I mean, we would have, to do this ideally, we would have to have like input from people in the community, people more experienced in certain areas. But then there's also, the issue of actually going to like the literature, looking at literature reviews and being able to, this I think is basically a way to organize it. I think Jesse's thinking of organizing it for himself, more like just to put different things together. But yeah, I think there is that opportunity for like community input for people who are doing work.
Yeah, definitely.
In
So of course, I'm talking about more if we are, going to do it like as some external resource, not just for our group, but also provided to some other people in all of the niches. So, some working product, some learning platform. I was thinking about this more. Of course, if it's only for our use, well, we can just do a simple review. It's fine.
Yeah.
And maybe add to it altogether.
Okay. Yeah. Well, yeah, that sounds good. Thanks for the feedback. We'll talk about that more in coming weeks.
We can talk about this later, of course.
Yeah.
Yeah.
So well, thank you for attending. Z, did you have any questions? I know you've dropped off for a minute there.
Nope. I will look at the videos to see what's happening.
Okay. Okay. Thanks for meeting. Talk to you next week, guys.
So, guys,
all right,
next
bye.
week.